Breadth First Search, or BFS, is a graph traversal algorithm. It can be used to find the shortest path between two nodes, if the graph is unweighted, to find all neighbors within a certain distance, to generate moves in games like chess, and for many other tasks. Imagine that we have a social network, and we want to find out how far from this person is this person. Using BFS, we will search in layers. First, immediate friends, then second-level friends, and so on, until we find the person we're looking for, or until we decide to stop searching because this person is too far. One of the ways to implement the BFS is to use a queue. We start with the initial node or vertex and iterate over its first-level neighbors. For each neighbor, we check whether it's the vertex we're looking for. If yes, we're done. If no, we add it to the end of the queue. When we finish handling the current vertex, we take the next one from the queue and repeat the process. But now we encounter our first problem. One of the first-level neighbors of the current vertex is our starting point, and we've already processed it. To avoid an infinite loop, we need to keep track of the vertices we've already looked at. For that, we can use a set. When we process a vertex, we add it to the set to mark it as visited and avoid dealing with it a second time. So we add our first vertex to the set and start again. Now, before processing each neighbor, we check whether it's already in the set, and if so, skip it. If not, we add it to the set and process it as before. We continue until we reach our destination node. If we reach the end of the queue, that is, the queue becomes empty, it means that we traveled the entire graph, and alas, didn't find what we were looking for. Now we're done, and we have our second problem. Yes, we found our destination, but how far is it from the starting point, and what's the actual path? To answer these questions, we're going to convert our set into a map. Instead of adding the next vertex to the set, we will add it to the map as a key, with the value being the vertex we came from. In our picture, it's the top vertex. Note that the vertex we started with, at the top of the map, doesn't have the previous vertex there, and it allows us to stop when we use this map to build the path. I hope this part is clear enough. I just want to avoid repeating the animation using the map instead of the set. So now we have a map and can use it to reconstruct the entire path and calculate its length. Of course, there are tasks where we don't need to build an entire path, but rather just need to iterate through vertices one by one, for example for flat filling part of an image. We start with the initial pixel and then use BFS to go over all its neighbors, checking whether their color needs to be changed. In such cases, using set would be enough. Alternatively, if we needed to know only the distance, but not the actual path, we could modify the queue to store levels together with the vertices, marking first-level neighbors with 1, second-level neighbors with 2, and so on. Two things to note here. First, the path we've found is not necessarily the only path of this length. There could be more, and which one we find depends on the order in which we iterate over neighbor vertices. And second, the path we just found is the shortest only for an unweighted graph. If the graph is weighted, for example a road map, where each road has different length or travel time, then the path we find using BFS is valid but not necessarily the shortest or the fastest. To find the shortest path in a weighted graph, other methods are used, such as the Dijkstra algorithm. This is it about BFS. Please let me know if you like this video or if there is something I need to change. Thanks for watching.